Hello, everyone. My name is Boris Lacharnar. I'm software engineer at Dewesoft. I'm glad I'm here with you today to talk about an exciting connectivity technology. Hopefully, you will get some ideas how it can be useful for you as Dewesoft user and your projects. So first, let's take a brief look at the key points of this meeting. We will do first we will do some introduction to OPC UA, since this is a technology serving a wide range of applications. Then we will do an overview of Dewesoft OPC UA support, and you will see its work in action. And in the end, we can have some minutes for discussion left. So to begin with, in automated factory, we use sensors to measure what's going on in the physical world. Then the acquired data is transmitted upwards to operation technology levels. This is PLC, SCADA, etc. And there is some real-time automatic processing done, and some automatic actions are being done on the actuator level. So, but there is more and more need for real-time data by the management so they can take better decisions. It is becoming more and more important to deliver acquired data to IT systems. And there's the cloud. Cloud allows us to read data and control devices, things at any time globally. We have unlimited hardware resources, and therefore we have absolute scalability. So on cloud, we are able to run sophisticated algorithms on large data sets. By analyzing big data, we can prevent failures and avoid shutdowns, which gives us massive operational savings in the industry. So the people and the software are already connected to the internet. Now we put online also the things. Things can be machines, tools, devices, vehicles, and we gather live data from the things, which enables us to predict market demands, constantly adapt our supply chain. In this way, we can invent new business models and deliver customized products. This is what we call Industry 4.0, Industrial IoT, smart industry. But how do we deliver data anywhere, from sensors to IT systems and the cloud? How do we extract data from devices of different incompatible vendors, and how we get out of vendor lock-in? And this is where OPC UA comes in play. OPC UA is communication protocol and platform, which enables your industrial devices, PLC, data acquisition units, sensor networks, Linux gateways, to freely collaborate in complex tasks. It is an open standard, platform independent, so it can be run on Windows, Linux, Mac, Android. And it is quite easy to use. So OPC UA is able to put thousands of devices under the same internet URL. It's OPC TCP / something. From there, you can control the devices, fetch the data, monitor their state, etc. It can be used in enclosed network or on the internet. It will work on any standard physical connection. It can work on wireless, optical, or Ethernet. Security is already taken care of, and this is real good because you don't have to implement your own security software. As a platform, OPC UA includes other functionalities that are useful in industry. We have discovery services, browsing capability, information modeling. And lately, also OPC UA is entering a real-time control field with time-sensitive networks, to support time-sensitive networks. So no surprise, it's gaining popularity and dominating market share in M2M interop protocols. So you can see OPC UA possible applications can be huge. And here are some. First is bridge structural health monitoring. In this case, we acquire vibration data continuously and analyze frequencies. With wear and corrosion or load, the frequencies change. So by constantly monitoring crucial parameters, we can effectively and affordably prevent collapses and disasters like this in Italy a few years ago. Condition monitoring on the bearings by measuring noise, vibration. This is another possible application. With analyzing data coming from sensors, we can effectively prevent failure. We can even predict time of probable failure. In the end, we prevent damage and reduce downtimes. And this means huge cost savings for us. And there are remote facilities like remote mines or pipelines, which are very wide range structures. Those can be remotely controlled by OPC UA as well as monitored. We can run remote diagnostics in case of anomalies. So there are numerous other areas and possible applications where you can use OPC UA. We at Dewesoft implemented two plugins for Dewesoft X3. It's OPC UA Server plugin and his brother OPC UA Client. With the Server plugin, we can deliver data to one or more clients. From outside, you can read or write to Dewesoft channels or control Dewesoft acquisition. So in real life, Dewesoft OPC UA Server can be used if you wish to access Dewesoft data or control Dewesoft from SCADA, cloud services, mobile devices, like third-party clients. And there is OPC UA Client. With the OPC UA Client plugin, you can connect to any OPC UA server and fetch the data into Dewesoft to analyze it, visualize it, design HMI from Dewesoft, control the unit, etc. So we can connect any third-party OPC UA unit with Dewesoft, be it machines, incompatible sensors, PLCs, and Dewesoft future devices. So we will now look at some examples we prepared here at Dewesoft and show around the functionalities and configuration. So what we see here is an ongoing measurement. We run this at Dewesoft headquarters. It's running 24/7. It's monitoring our server room. Now we will stop this to show around what we are measuring. So on the input, we have one Sirius and a couple of sensors. So there are we measure sound level, temperature, and acceleration. And we have also some derived channels in the math tab. So here we have average and RMS. This is all running at very low rate. Raw data is running at 100 Hertz and statistics at even 1 Hertz, which is quite enough for this purpose, the purpose of this application. And it might be reduced even more. So on the OPC UA Server plugin, we just check the channels that we want to publish. So these are already published, and let's say we want to publish another channel from sound level. So now we go to measure, and this way we enable the data exchange with the clients. On our local computer, on client side, we have client plugin installed. We can see the server connection is darkroom and it's not defined yet. So we should add this under settings. We locate the client OPC UA Client plugin under extensions, and we add a new server. We will name this dark room, and the IP is it's here 10.10.2.170.17, and we use default port, so it's 4840. Okay, and you can already see the client is online. So click OK. And now our server is available here on the list. From the browser on the left, there is OPC UA information structure, which is hierarchical structure, and it's quite easy to find certain channels or data sources. So we now enable channels one after another. We will add scaled values for temperature and the acceleration, and we will add sound level. So we can check this under channels tab. The data is already acquired by the server. So now let's go to the measurement and see the results. Okay, there's another thing. I need to disable this one. Okay. Controls. Okay. Let's auto scale this. So this is live measurement of the OPC UA server. So from at this side, on server side, we are taking live measurement from measurement unit. And on the client side, we are taking measurement of the OPC UA server state. So you can see, for instance, this is sound level, and it looks similar, but you would see that patterns that patterns match left and right. So if you check this portion is similar to this portion, etc. So this is same data we are getting on both sides. So let me show now some more features of the client. Important functionality is sampling rate. This is the rate at which a client takes data from the server. So default is 100 Hertz. In low rate applications, we can lower this setting. If we deal with higher rate data, we can push this upwards. So I don't know, we can put 300 Hertz, and you can see throughput. In throughput, you can see the download rate at which we are acquiring the data from the server. So we will lower now this, and the throughput is quite lower. Have in mind that a higher sampling rate can generate more requests to the server and more network overhead. So you should test what setting works best for your application. In setup, we can also change units, and we can change color of the measurement data. All the changes are stored in setup file, so we can also see status of separate channels here, and otherwise it will be bad unknown or error or something. How to combine data from more sources. Usually OPC UA Server represents one measurement unit. You can add additional servers to the acquisition and combine data from different sources. So you can do some sensor fusion. For this purpose, we will use channels from our another project. Just a second. So this is machine shop setup. It's monitoring application that is also running 24/7 at Dewesoft remote machine shop facility few kilometers away from here. There we monitor acceleration on CNC machines as well as rotating speed of spindle to analyze possible wear. So this is the current data, but unfortunately the machines are not running, but we can see still something's going on the spindle. So on the client side, we have already defined a server, and we can add some new channels to it. And we will add spindle RPM. And we can see the value is changing, and it's being mirrored from the server side already. So we go to measurement. We add another control with this spindle, and here you can see many sources combined in one measurement plane, which is useful for analysis, sensor fusion, visualizations, HMI, etc. So let's go to another example. Okay, so in the examples before, you could see the speeds up to 100 Hertz, but at Dewesoft we designed OPC UA solution that can manage much higher speeds. We call it DUC profile. So now we will demonstrate this in action. We have one server running acquisition at 1 million samples per second. So this is just simple step channel, and it will be fine for this demo. So on the other side, we run OPC UA Client, and we have, I think the server is already added, and we are online. So, but for this case, this is high-speed acquisition, and we really need to check the settings. So we go to settings and check if the channel sample rate is really right set. And another thing that is important, with high-speed synchronous channels, we prefer master clock, because in soft sync the data gets converted from synchronous to asynchronous data. So we don't want that. So here we check master clock in OPC UA Client settings. The assumption is that the clock on all nodes are perfectly synchronized. And we also have to check dynamic acquisition rate. It's under analog in. So this also has to be pushed up. Okay. And we add our channel. And we check the acquisition. The acquisition is already running. You see the throughput, 1 million samples per second. And let's see how the measurement looks like. Okay, so this is the measurement at 1 million samples per second over OPC UA through the internet. So sure, this depends on the network reliability and bandwidth, but we have managed to bring the speed from million to 15 million. So OPC UA is really fast in this sense, so no worry. We can also show around to freeze, and we can see all the samples are here. So we would expect our samples, million samples per second per one step. Okay. Okay, so this is the DAC profile. Another useful thing is remote control. So you can run any custom methods that are defined on the server or write into channels as well, change remote variables or properties. Let's check how this is working. So on server side, we've already exposed one variable, which is here. And on the client side, we will now add this variable so we can change it remotely. I have another setup just prepared for this. Okay, so we've registered this variable to OPC client and two methods that are exposed by OPC UA server. So these are start and stop acquisition. So let's check how this works. On client side, I can change the value, and you can see on the server side the value is being changed. Then I have two buttons, start and stop, so I can stop acquisition, and now I can expect error on the client because monitoring has been cancelled. And this is in normal process, this is not good. But I can also start it and resume the measurement. So this was remote control. Now we have another project. Another example. We want to show a third-party client working with our OPC UA server. So as you can see, here is Android tablet, and it's taking data from our server, from our application. Let's see the server side. And this is it. So this is this is an application running in Dewesoft headquarters. We are measuring electricity quality and electricity use in our building, and you can see we can connect by third-party client, which is not Dewesoft. We downloaded it from Google Store, and we can connect to Dewesoft and see the data real time. So you've seen all this possibility. for use of OPC UA client and server solutions we've developed here at Dewesoft. And let's summarize some possible use cases. There are three combinations. You can use server plugin, you can use client plugin, or you can combine both. So with server plugin, you can acquire data from third-party devices like phones, SCADA, HMI, and so. With client plugin, you can acquire third-party data to the Dewesoft, so you can analyze it and process it and so on. So and you have client plus Dewesoft plugin, client plus server plugin, so you can transmit fast data in between both sides and build large distributed installations. So you can download trial plugins from downloaddewesoft.com, and the material is available at Dewesoft Pro webinars. And it will be also uploaded to our YouTube channel, so you can also subscribe. These links will be also put in the show notes. So thank you very much for your attention. I hope you enjoyed it. For additional questions, you can address to support.dewesoft.com, and don't forget to subscribe to our YouTube channel. Thank you.